And in this session, we are going to look at the random forest regression. We learned about random forest in the last session, and there was something about random forest. Basically, we talked about that it optimizes the decision trees. That decision trees causes overfitting, and random forest does many decision trees in parallel, and then randomly like chooses kind of have does some ensemble algorithms to choose the right to choose an optimal decision tree algorithm to use, better by doing an average or finding a maximum at a particular. It depends on the configuration. So we're going to look at the random forest algorithm in this session. So let's begin. Um, let's add our tests and random forest. Is that a spelling of forest? I'm not sure, but I think it's one S. One is one R. Forest random forest algorithm. As a programmer, you always make mistakes with words. Okay. Um, one thing about random forest algorithm, with the linear regression is actually nice. It's really good for scaling, for training with large data. But difficult with linear regression is it always believes, yes, I think that's the right word to use, believes that all data has a form of linearity in it. You get. So that's one thing that you always, and that's not always, because in real life our data are mostly non-linear in nature. So but random forest could actually work with linear and non-linear, but it's also open to, if a data is non-linear, yes, it could also do well. But if a data has much non-linearity in it, linear regression doesn't cope well. But random forest decision trees, yes, they do very well with that. So we'll compare the performances and we'll see how it goes. So first of all, we have to import random forest. So that's a from sklearn dot assemble. Assemble is actually the algorithm it uses to optimize the different decision trees on its own stack. So hopefully that's the namespace that they used to save it in, and they used for it in sklearn. So you just self-explanatory. So we import it, then we create an instance of it. Random forest. Okay, I think that's a good short form. Then we call, and basically because it actually does some assembling to kind of randomly choose um a the decision tree to use, decision algorithm to use. So we have to pass in the random state. This ensures that every time we run this algorithm, every time we run this algorithm, it's it is reproducive. It's reproducive. Yeah, that's what it does. Once we assign this to a value, anytime we run this algorithm, we always get the same results. We always get the same result, but it's random, but we also get the same results. So that's the reason why we pass this. I think it's an optional argument. It's not really important, but yeah, we'll just pass it because we want something reproducible. So we name this model this time around, so we don't have some issues with our test period and all of that. It's good to keep up with naming your stuff. It's really nice. So fit, as we already know, then we call the trend features. Sorry, yeah, it's trend features. Optimize columns. Then we call the train. We'll be faster this time because we already know what we are doing. Uh, then let's run it. Hopefully we get no error. Okay, and we call the prediction mean squared. We not use mean squared this time around. We use this, using square root of mean squared is RMC. That's root mean squared. So yeah, let me just write it down here so you get to understand what I mean. Uh, that's it. Sorry, in Python is always like this. RMC, yeah, root mean squared. So we call the SQRT mean squared. No, sorry. Before we make this, before we write it, we have to. Sorry, we have to make a prediction on the model before we do that. Predict. You can see it's more intuitive now, and you can understand that we're using the model. The model is predicting on it. The model has the mapping, so it's predicting on the new data. So I think it's better you understand this. The last time we use it very poor name, so I apologize for that. So we'll make a prediction and optimize, test features, optimize quorums, and after making the prediction, we assign the result to np dot sqrt, which is our RMC, which mean squared error, and then we add our pred and our test sales price. Okay, then we print our results. Okay, we can see that it's 498098. That is, this one was better than it. And as a machine learning practitioner, once I see this, I just know that this house data set is kind of linear. It has this form of more of linearity to it. Like I said earlier on, if there is so much linearity in the data set, linear regression does very well. But if they are not, the random forest is if they are not, the random forest does very well. So that's it. So now I know that okay, this data has much of linearity, so linear regression is best. Linear regression is always the best for any type of machine learning tasks, but it's just a data doesn't obey a linear nature. Is so difficult for it. So hopefully you have gotten some understanding about machine learning and supervised learning regression algorithms, and hopefully you're okay with it. And I'll see you in the next session. And thank you very much.